All right, so let's start part 2 of 4.4. So first, let's just talk about standard form of these quadratics. So you're going to have whatever term is the x squared should be written first for it to be in standard form. Then you're going to write so the x squared term is first, and then just the x term and the constant term, which is just a number. Okay, so whenever you're doing this, of course, always look for a GCF, a greatest common factor, to look for in all of the terms. If there is one, factor it out. If there's not, then go to the next step. So the second step is to use the product sum puzzle to factor the trinomial. And then we're going to rewrite them as 4 terms, then factor by grouping like we did in the last lesson. So whenever you're doing these, you need what multiplies to be the C term and adds to be the B term. Okay, so multiplies to be the constant term, and adds to be the middle term. So let's think of this. So this one, we need something that multiplies to be 8 and adds to be 6. Okay, so it's going to be 2 numbers. Can you think of them? It is 2 and 4, right? So 2 and 4. So let's rewrite this now. We're going to have x squared plus, and it doesn't matter the order you write the 2 and 4, but I'm going to write it this way just because. So I'm going to put the 2x right there, and then plus 4x, which is obviously this piece right here, and then just bring down that plus 8. Okay, so as you can see on this one, if you were to combine like terms, which we don't want to because we just split them apart, but if you combined like terms right here, you would get this exact same thing, right? All I did was split up this 6x into 2x and 4x, okay? So let's go ahead and factor by grouping like we did in the last video. So I'm going to do, out of these first two, what can you divide? Looks like you can just divide an x, right? So that gives you x parentheses, and then x squared divided by x is x. Positive 2x divided by x is positive 2. Okay, the next set of parentheses, or the next 2 terms, looks like you can factor out a 4. So I have a positive 4 parentheses. 4x divided by 4 is x. Positive 8 divided by 4 is positive 2. All right, so this is the step where you have to check. Do your parentheses match? Yes, they do. Sweet. So I'm going to take the stuff that's on the outside of the parentheses first. It doesn't matter. You could do the other stuff instead, but you're going to have x plus 4 times x plus 2. And you just factored. If you wanted to distribute out to check your work, I'll show you how really fast. I won't do that. I'll just do it for this first problem. So x times x is x squared. X times 2 is positive 2x. Positive 4 times x is positive 4x. Positive 4 times 2 is positive 8. Then combine your like terms. So you have x squared plus 6x plus 8. Is that the original equation? Yes, it is. Perfect. You are finished. So the answer that I boxed is the correct answer. Okay, let's do another one. Can you factor anything out of all 3 terms? Nope, it's not looking like it. So this is the part that people struggle with. Pretty soon you'll be good at it, and this will be super fast for you, but sometimes people struggle. So I need something that multiplies to be negative 15 and adds to be negative 2. Okay, so let's talk about a few things. If you are multiplying, and you might want to just do this off to the side, if you are multiplying 2 numbers, if you have a positive times a positive, it's going to be a positive, right? And if you have a negative times a negative, that would be a positive as well. If you have one positive and one negative, that's going to be a negative. So in this case, since I'm trying to multiply these numbers will multiply to give me a negative answer, I know I need a positive and a negative. So I need 1 and 1. All right. So the next thing, whenever you are adding, let's write this down too. So whenever you're adding, if you have a positive plus a positive, that's obviously going to be a positive, right? And a negative plus a negative is going to be, actually I'm going to change the colors of this so it's a little bit better. Come on, stupid thing. All right, sorry. Okay, so if you have a positive plus a positive is a positive and a negative plus a negative is a negative, right? Easy, okay? So, but whenever you have a positive and a negative, the sign, you keep the sign of the bigger number, right? So, in this case, we're wanting two numbers that add to be -2. So the bigger number would have to be a negative, okay? So for this instance, the bigger number is negative because of whenever you add signs, I'll say it one more time, whenever you add two different signs, you keep the sign of the bigger number. So, all right, so I know I need a positive and a negative, so a positive and a negative, and my bigger number is going to be negative. So let's think about it. Sometimes if you're stuck, it might help just to start listing the factors. Sometimes I do this whenever I start getting to really big numbers and it's kind of a mess. So we have like 1 and 15, right? 2, no, 3 and 5, right? So 1 and 15 is not going to ever add to be -2, right? No way you can work it. But 3 and 5 looks like it will. So in this case, our numbers, remember we said the bigger number needs to be negative. It'll be -5 and +3. Alrighty. So let's rewrite that middle term so we can factor by grouping. I'm going to have x squared minus 5x plus 3x minus 15. Quick check, if you were to put those middle two terms back together, would you get -2? The answer is yes. -5 plus 3 is -2. So good. All right, let's factor by grouping. So out of these first sets, looks like we could take out an x. So that would be x times x minus 5. Looks out of these next two terms, you can take out a 3. So a +3, you get x minus 5. All right, sweet. So looks like our parentheses match, so let's put Humpty Dumpty all together. So I have x plus 3, and then I have what's inside the parentheses, x minus 5, and remember you just write it one time. All right, that is your answer. Let's do a few more. So I'm going to start speeding up just a little bit. So I need two numbers that multiply to be -4 and add to be 3. So remember, if it multiplies to be negative, it's going to be a positive and a negative number. And since there's 1 and 1, one of each type, and they add to be positive, we know the bigger number must be positive, right? So in this case, I believe it is 4 and -1. 4 times -1 is -4. 4 plus -1 is 3. Yes. Okay, so I'm going to write it. X squared plus 4x minus x minus 4. Okay, so what can I take out of the first one? Just an x. So this would be x plus 4. Now looky here, so I have -x minus 4. It looks like almost exactly what we need, but we need to switch those signs around. And if you remember from the last lesson, to switch those signs around, we have to divide by -1 or factor out a -1. So this is going to be -1 times x plus 4. All right, do your parentheses match? Yes, they do. So I'm going to have x minus 1 times x plus 4. Boom. Okay, this one's a little different, but first, what do you notice? I notice that we can divide all of those by 2, right? So let's factor out the GCF. So this is going to be 2 times x squared plus 3x plus 2. Okay, so now disregard that 2 out front, but don't forget about it because it does come back into play. So some people will just forget it and leave it off and the answer will be wrong. So just don't be one of those people. So we need two numbers that multiply to be 2 and add to be 3. So since they are both positive, we know we need two positives, right? Because if two numbers multiply to be a positive, it's either two positives or two negatives. And since they add to be a positive, we know it has to be two positives. Okay, so in this case, it looks like it would be 2 and 1, right? Because 2 times 1 is 2 and 2 plus 1 is 3. So I'm just going to write that first 2 out to the front. No big deal. Don't even worry about it. Just write it out there. So then I'm going to split up that middle term into positive 2x and positive x, and then drop that down, that plus 2. Okay, so now let's see. We're going to divide these two front two pieces by x. So I'm going to have 2. I'm just going to have some giant parentheses. It's all right. So we're going to have x times x plus 2. Then looks like these ones, I don't need to factor out anything because they're fine. So whenever you don't want it to change at all, what do you factor out? A positive 1. So divide by 1, so that would just give you x plus 2. Right, put it all together. So I have 2 out front times these two pieces, so x plus 1 times what's inside the parentheses that is matching, x plus 2. Boom, we did it. Okay, ooh, this one. What can you factor out of this one? No numbers, but they all have an x term, right? So I can divide everything by x. So it's very similar to the last one. I'm going to have x squared minus 4x minus 12. Okay, so let's go ahead and do our product sum x. So we need something that multiplies to be -12 and adds to be -4. So remember, if it multiplies to be a negative, you need a positive and a negative, 1 and 1. And then since it adds to be a negative, you know your bigger number is going to be negative. All right, and so let's go ahead and think. I believe on this case it would be -6 and positive 2. Yes. So remember, you have x, and then just leave it out there. It's not going to hurt anything. So I have x squared minus 6x plus 2x minus 12. All right. So another giant parenthesis. So I need to divide these by x, right? That's all you can do. So that gives me x times x minus 6. Divide this by 2, and it would be positive 2 times x minus 6. Do your parentheses match? Yes, they do. So let's put it all together. Don't forget that x out front. So I have x times the stuff out front, x plus 2 times x minus 6. Boom. Okay, this one, what are you going to do? It's getting crazier. This time it looks like you can do an x, of course, because they all have x terms. And then you can also do a number. So let's do 3, right? Because they are all divisible by 3. 3 and an x. So we have x squared plus, this case would be 2x, right? And then minus 8. so let's go ahead and see. We're going to leave that 3x out front. We need something that multiplies to be -8 and adds to be 2. So since it multiplies to be -8, we know we need a positive and a negative. Since it adds to be a positive, we know the bigger number needs to be positive. So let's go ahead and do this. This looks like it would be +4 and -2. Yes. So get it all written out. So 3x times x squared plus 4x minus 2x minus 8. Out of those first two terms, looks like we can factor out an x. So I have, what would that be? X parentheses, x plus 4. And then on this other one, it looks like we need to factor out a -2 because we want both to be positive. So -2, and that would give you x plus 4. Perfect, exactly what we wanted. Now let's put it all together. 3x out front, then x minus 2, then x plus 4. Okay, one thing I haven't really talked about, but I should. Whenever you're writing these two groups of parentheses in your final answer may be switched around, and that is 100% okay, because remember, you can switch stuff around in multiplying. The only thing is this one right here, sometimes technically it's not wrong if you write it in the back, but just kind of some math grammar is if it doesn't have any parentheses like this, you stick it on the front. So just to give you a heads up on that. But I wouldn't count it wrong, but yeah, don't do that. All right, so let's go to the last one of these ones. Okay, so it looks like on this problem, if you notice, every time we've factored let's go back. Every time we've factored, the first term has been x squared, right? All of those have been x squared. So, or after, whenever we factor out the GCF. So just know that is the easiest way to factor. So let's see, what can I do to get that negative off of there? Well, you could factor out a -1, right? So this would be -1 times x squared plus 5x plus 4, right? So then we're going to need two numbers that multiply to be 4 and add to be 5. So those are going to be two positives, and it would be 4 and 1, right? So this would be -1 times x squared plus 4x plus x, 1x, plus 4. All right, looks like we can divide both of those front two by an x. So I have x times x plus 4. And the back two, we don't need those to change at all because we want it to be x plus 4. So let's just take out a 1, a positive 1. So +1 times x plus 4. Okay, now let's put it all together. So I'm going to have -1 times x plus 1 times x plus 4. Another thing you may see this, that way is perfectly fine. If you see it like this, just know it's the exact same thing. So if they just have a negative out front, it's the same thing. Okay, now let's talk about when the leading coefficient is not 1. So when the a term is not 1, you have to do one more little step, okay? Otherwise, it's the same thing. So you solve this almost the same way as you did the others, except there's one more step. When finding what numbers to multiply, you have to multiply a times c. And a lot of people will forget that. So I'll write it over here. So if I'm making my product sum x, so usually we would just say what multiplies to be 6, right? Well, in this case, we need to see what multiplies to be 5 times 6, aka 30, right? So, and then we still need what adds to be the middle term, -13. So that is just one more step. And you, again, you only have to do this if that number out front of the x squared is not 1, or they put a number there. So this can kind of be a pain sometimes because the numbers start getting a little bit bigger, but that's okay. So it looks like we need either 2 positives or 2 negatives because that 30 is positive. But since the 13 is negative, we know it needs to be 2 negatives. Okay, so what multiplies to be 30 and adds to be negative 13, but 2 negatives, that'll be negative 3 and negative 10. Okay, so I'm going to write it out. So I have 5x squared minus 3x minus 10x plus 6. Okay, so as you can see, I didn't change it at all. I just split apart the middle term. Okay, so now let's do our factoring by grouping like we did in the first lesson. So it looks like out of these first two, you can divide them just by an x, right? So this would be x times 5x minus 3. This one looks like we can take out a 2, so divide by 2. And this would be negative 5x plus 3. But wait, remember, we don't want, or the parentheses don't match, but they're really close. They're just off by a negative signs and positive signs. So let's, instead of taking out or factoring out a 2, let's factor out a negative 2 here. So that would cause that to be positive 5x, and that would cause that to be negative 3. Perfect, because now our parentheses match. Let's write it all together. So we would have x minus 2 times 5x minus 3. Okay, next one, we need 2 numbers. Remember, don't miss the step that multiply to be 2 times negative 3, aka multiply to be negative 6, and add to be 5. So since they multiply to be a negative, we know we need 1 positive, 1 negative, and then we need the bigger number to be positive. So this would be, what would it be? Sorry, I'm drawing a blank. 6 and negative 1? Yes. Okay, now let's rewrite it. 2n squared plus 6n minus 1n. I'm just going to put minus n minus 3. Oops, don't need parentheses yet. Okay, it looks like you can factor out of those first two a 2n. So that would give me n plus 3. All right, now I need an n plus 3, but we know these are both negative. So I'm just going to factor out a negative 1. And this would be n plus 3. Put Humpty Dumpty together, and 2n minus 1, n plus 3, boom. We did it. Okay, let's do a few more. So out of here, we need 2 numbers that multiply to be 2 times 40, sorry, I said the answer, 2 times 20, which would be what multiplies to be 40, and adds to be 13. Ooh, I gotta think about this one for a second. Okay, so I'm not gonna lie, I pause the video, and then I'm like, hey, this is an obvious answer, but if you already see it, great, you're smarter than me. But if not, if like sometimes this happens and you just have a brain fart like I just did, here's what I would do. I would start listing the factors of 40. So 1 times 40, right? 2 times 20, 4 times 10, 5 times 8. And you also have that cheat sheet if you have seen me in class and I've given that to you. That helps too. So here it is. We got this one right here. That's going to do the trick because we know this is going to be 2 positives. So this will be 5 and 8. All right, let's split it up. We have 2r squared plus 5r plus 8r plus 20. Those first two, let's take out an r. So I have 2r plus 5. Those second two, I think you can just take out a 4. That's it. So if you're taking out a positive 4, you get 2r plus 5. Perfect parentheses match, so I have r plus 4 times 2r plus 5. Boom. Okay, so now let's do we have a couple more. Oh gosh, this is going to be a long video, I'm sorry. So let's do this one. We need two numbers. This is getting crazy. That multiply to be 2 times 28. So they multiply to be, what would that be? 56, and add to be 15. This one came to me, it'd be 7 and 8. I'm going to start going quicker, I'm sorry. So we have 2p squared plus 7p plus 8p plus 28. Let's factor it. Out of these first ones, you can just take out a p, and you get p times 2p plus 7. Looks like out of this next one, you can factor out a 4. Yes. So positive 4 gives you 2p plus 7. The parentheses match. Sweet. So I have p plus 4 times 2p plus 7. Okay, I'm going to skip these next two and go to special cases. So special cases, comes up a lot, or not a lot, but sometimes. So if you have just two terms and they say to factor it and there is a minus sign in between, and they are both perfect squares, which means you can take the square root evenly of both. Then you can split it up into, so your first term, whenever you take the square root of a squared, you get a. So they put an a first. And then whenever you take the square root of b, don't worry about the negative at this point. When you take the square root of b, they put that term second in both sets of parentheses. And then they put one parenthesis with the plus sign, one parenthesis with the minus sign. Okay, let's do one. So is there two terms? Yes. Are they being subtracted? Also yes. Can you take the square root of them because they are perfect squares? The answer is yes. So in this case, the a, when you take the square root of the first term, would be x. And the b, the square root of 81, is 9. So this would be x plus 9 times x minus 9. Or you could flip-flop it around if you want. Kind of easy, right? This one, 4a squared minus 16 squared. So this is getting a little different. The a, what would be the square root of that? Well, remember you can break that apart into the square root of 4 and the square root of a squared. So that would be just 2a. And b, the square root of 16 is 4. So this would be 2a plus 4 and then 2a minus 4. All right, let's do two more. Okay, so there's two terms. Yes, perfect. Are they both perfect squares? Yes. But red flag, they are not being subtracted. So don't let this mess you up. Since they are being added, this is unfactorable. You cannot use this. It must be subtraction. It's literally called the difference of squares formula. Okay, so you can't do that one. Let's go ahead and go on to the next one. This one is two perfect squares being subtracted. The a term would be b. It's kind of weird. And the b term, square root of 121, is 11. So this would be b plus 11 times b minus 11. All right, that is it. Sorry the video is so long. Have a great rest of your day.